in chemistry, topics are interrelated. So you may find like one part is from chapter 1 and another part is from chapter 8 or 10. So once you complete whole syllabus of chemistry, you will be able to solve all the question. So specifically the topics which you already studied, we'll discuss those. In this one, question number 1A, proton, neutron, and electrons are subatomic particles. Complete the table to show a relative mass and charge of proton, neutron, and electron. You can use the screen annotation to write on the screen. How you complete this table? The screen annotation is enabled, so you can just write the relative mass. Yeah, that's correct. Thank you for your participation. It's relative mass of proton is 1, electron is also, neutron is also 1, because relative means comparison. So 1 here refers to they have the same mass, but electron are the lightest. When we say a charge, proton is relative charge is +1, electron is -1, and neutron is 0. Bromine has 2 isotopes. Define the term isotopes. How you define the term isotopes? Definition of isotope.
The atom of an element that has the same number of protons and the same number of electrons and protons, except that the neutron number is different.
Yeah, so atoms of same element with different neutron number or same number of proton, or you can say different atomic mass, same atomic number. Called isotopes. Next is explain why 2 isotopes of a bromine have the same chemical properties. Chemical properties. Yeah, that's correct, Umar. Ahmad Umar. Why do isotopes have the same chemical properties? What is the reason for that?
Because they have the same number of full outer shells, full electrons in the outer shells.
Same number of electrons in the outer shell.
Yeah.
So why do the chemical properties same? Because they have same number of outer shell. The table shows the number of proton, neutron, and electron. You have to fill this table. Use the screen annotation to complete this table.
Sir, it's very difficult to annotate with the mouse.
I'm also using mouse to write the things. When I'm writing this all, I'm using a mouse as well. The important thing is the participation, which I can judge the understanding. So I want everyone to participate. Uh, for potassium, you have to write the mass as well. Potassium symbol is correct, the mass, and if there's a charge or no, that you have. The first one, lithium, which contains 3 protons and 3 electrons, how you identify from atomic number. And the difference 7 minus 3, that's equal to 4. So the first row is correct. Proton number is 16 for sulfur. How to find the number of the neutron? The number of the neutron is a difference. How to find, like in this case, 7 and 3, so 7 minus 3 will give us the number of the neutron. Same thing, 34 minus 16 will give the number of neutron, which is 18. And how you'll identify electron number? If it is negative charge, means electrons are more. If it is positively charged, then protons are more. For the last one, you can see there are 19 protons and 18 electrons. So it means there should be a plus charge. Is it clear, this table? Okay, part D. Silicon 4 oxide has a giant structure. Name type of bonding in silicon 4 oxide. What type of bonding is there in silicon 4 oxide? There are 3 types of bonding: ionic, covalent, and metallic. What kind of bonding is there in silicon 4 oxide?
Covalent.
Covalent bonding. And the next part is 2 physical properties of silicon 4 oxide. 2 physical properties. Like physical properties refers to melting point, boiling point, and
High melting point.
high melting point,
Boiling point.
right? High melting and boiling will be considered as one. What else?
Doesn't conduct electricity.
Does not conduct electricity. Because there is no free electron or charges, so it does not conduct electricity. Next, calcium phosphate is used in fertilizers. The bonding in calcium phosphate is ionic. Calcium phosphate contain iron phosphate, which is PO4 with a charge -3. What is ionic bonding? How you define ionic bonding? What is the definition of ionic bonding?
The strong electrostatic forces between the oppositely charged ions.
Yes, that's correct. So bonding between not two non-metals, the bonding between metal and non-metal. Due to complete transfer of electron. You will not write this as an answer, and this part is for explanation. What the answer, correct answer is, I will mention. So bond between the metal and the non-metal due to complete transfer of electron. But what we call specifically ionic bond, the electrostatic attraction between positive ions So the strong or the electrostatic attraction between the unlike ions of positive and negative ions, we call that as ionic bond. One mark is for positive and negative ion. All the bonds are stronger. If the bond is between metal and non-metal, it will be ionic. If it is the bond is between the non-metal, it is covalent. Calcium is a metal, phosphorus and oxygen are non-metals. So that's why metal is there and the non-metals are there. That's why the bond will be ionic. Deduce the formula of calcium phosphate. So how you deduce the formula of calcium phosphate? So calcium is a group 2 element, so charge or valency will be +2, and phosphate valency they already give you -3. When you write a formula, you cross multiply the valencies. So it will be Ca3PO4 in a bracket 2. Is it clear? This is how we write a chemical formula. We just cross simplify, we write the valencies, then we simplify the valencies and then cross multiply. Sulfur tetrafluoride can be made by combining a gaseous sulfur with fluorine. This is the same question we did yesterday. The reaction is exothermic. Complete energy diagram, include an arrow which clearly show energy change. So where I should make a product, up or down? It's an exothermic reaction. Yes, Salah? So because it's an exothermic reaction, so I should make the product down, and the arrow should point from reactant to product, and the arrow should point downwards, and I will write the product SF4 in a gaseous state. That's it. Is it clear? This energy diagram for exothermic reaction. Next part, during the reaction, amount of energy given out is 780 kilojoule per mole. The FF bond is 160. Use information, find SF bond. So the formula is bond breaking minus bond forming is equals to energy change. So when you break the bond and when you form the bond, you will get the energy change. First, the bond breaking side, the reactant side is the bond breaking side, and the product side is a bond forming side. So bond breaking, here there's a sulfur atom. Sulfur atom does not have any bond, so there is no bond breaking for sulfur. But we are breaking fluorine bonds, and how many bonds we are breaking? We are breaking 2 fluorine bonds. So bond breaking will be 2 multiplied by fluorine, because this is 1, this one is a second. Minus bond forming. How many bonds are formed? 1, 2, 3, 4. So how many bonds are formed? 4 SF bonds are formed. And that is equals to energy change. What is the energy change is given during a reaction? Amount of energy given out or energy released or energy change. If energy change, if it's a given out, it's an exothermic reaction. So we will put minus 780. If your energy is taken in, we will write plus 780. In the question, he did not ask for energy change. He is asking for bond energy. Energy change is given. So bond breaking minus bond forming will give us the energy change. Energy change is given. Using an energy change, we can find the bond energy. So for 1 fluorine bond, the energy is 160. So for two fluorine bonds, this is 160. This one is unknown. Sulfur and fluorine bond is unknown. And minus 780. 2 multiplied by 160, that's equal to 320. Minus 780. 320 is added there. Other side, it will be subtracted. So minus 4 SF is equals to minus 780 minus 320. Minus 780 minus 320 will make minus 1100. This 4 is multiplied, this minus will cancel with minus, 4 is multiplied, other side it will divide. So SF bond will be 1100 divided by 4. 1100 divided by 4, it will be 275. So what we did, bond breaking energy minus bond forming energy is equals to energy change. The energy change is given, the energy release is the energy change, which is 780. But we did not put 780, we put minus 780. Why? Because energy is given out. Whenever energy is released, the energy change should be negative. So bond breaking energy, what are the bonds we are breaking? We are breaking two fluorine bonds. That's why 2 multiplied by 160. And bond forming energy is 4 sulfur fluorine bonds are formed. So that's why it's 4 into. And this is a formula that bond breaking energy minus bond forming energy is equals to energy change. Then substitute the values and find the unknown. So you will get 275 kilojoule per mole. Is it clear? Because in this question, they asked for energy, they asked for bond energy, not the energy change. So during a reaction, energy is given out. So energy change or delta H is minus 780. This is a bond breaking site. So how many bonds we are breaking? We are only breaking 2 fluorine bonds, and this will be 2 multiplied by 160. So this will be equal to 320. And bond forming, the product side is a bond forming. So 1, 2, 3, and 4. So 4 sulfur fluoride bonds are formed. We don't know the value, so we will write like this, 4 sulfur fluoride bond. And the formula is bond breaking minus bond forming is equals to energy change. So bond breaking is 320 minus bond forming is 4 sulfur fluoride bonds equal to energy change, which is equals to minus 780. This is plus, other side it will be subtracted. So this will become minus 4SF is equals to minus 1100. Minus will negative will cancel with negative, 4 is multiplied, other side it will divide. So sulfur fluoride bond is 1100 divided by 4, which is equals to 275. Any doubt in this?